Hey everyone. We are asked to provide the ground state electron configuration of sodium in the standard and noble gas notations. So I recommend you take a minute now and try to solve this problem on your own before we go through the answer together. When finding the electron configuration of an atom, we are being asked where does that atom place its electrons, i.e. what shells and orbitals are its electrons most likely to be found. So, to solve this, the first thing we need to do is look at our periodic table and see how many electrons a sodium atom actually has in its ground or unexcited state. Looking this up, we can see that sodium is number 11 on our periodic table, meaning that in a neutral state, no positive or negative charge, our sodium atom will have 11 protons in its nucleus and thus 11 electrons surrounding that nucleus to maintain the neutral charge. Let's also remember, in the past video, we talked about this handy device for remembering which orbitals have the lowest energy, as these are going to be the orbitals that are going to get filled first. As I believe it makes things easier, I wrote the Bohr model of sodium here. This will help us keep track of our 11 electrons as we place them into our electron energy level diagram. So let's start by placing our electrons from the lowest energy state to the highest energy state, as shown by our diagram above. We always begin with 1s. As we discussed before, it is the lowest energy shell, and with the s subshell, it can hold 2 electrons. That leaves us with 9 electrons left. Next, following our arrows, we have 2s, which again can take 2 electrons. Next, we have the 2p subshells, and the 2p subshells can hold 6 electrons, leaving us with 1 remaining electron. Continuing down our diagram from above, we can see that that's going to be 3s. And we will place our 1 remaining electron within this 3s subshell. And we have placed all of our electrons. Now that we have placed all of our electrons into the energy level diagram, we can write out the electron configurations. Firstly, in standard notation, we have 1s2, 2s2, 2p6, 3s1. Then, we can write it in noble gas notation. The noble gas that is the next lowest to sodium is neon. Therefore, we can consolidate this portion of the standard notation and write sodium electron configuration as neon 3s1. And there we go. We've just solved for the sodium ground state electron configuration in both the standard and noble gas notations. I hope that this video helped your understanding of how to find sodium's ground state electron configuration. If you enjoyed, please like, subscribe, and consider checking out our YouTube memberships by clicking that join button down below. However, if you have any comments, questions, or concerns about the information I provided in this video, please leave a comment down below and I will do my best to address your concerns.